So for example number 4, and I'm going to zoom in a little bit. So can you guys see that in the back like that? Is that okay? Or do I need to zoom in? Anybody need it zoomed in? Okay, if you don't need it zoomed in, never mind. So this is the same thing. So now this is stretches and shrinks. So A not only can flip things, but it can stretch it. So if A is greater than 0, actually, let me back up. If A is greater than 1, then it stretches vertically. So that's a vertical stretch. If A is a fraction between 0 and 1, then it shrinks it vertically. And it doesn't matter what we do. It could be a quadratic. It could be an absolute value function. For example, we have 2 absolute value functions. And the factor is the number, right? So let's look at this. If I change this, right now I've got it set up for a quadratic equation. But if I come in here and I type in absolute value of a function, right? And then I come in here, change this, and I type absolute value of a function. The red function is the regular absolute value function. If I change this to +1, see what that does? It does the same thing. So when A is greater than 1, this is what I'm saying. When A is greater than 1, see how that stretches it vertically? As A increases, it's really stretching that vertically. Does that make sense? Now, when A gets to 1, it doesn't do anything. It just kind of stays the same. But now, when A is between 0 and 1, it shrinks it. It compresses it. Okay? So this is a fraction or a decimal. And as I get closer to 0, the more it compresses that. Okay? So that's what they're saying. So let's look at these 2 functions here. I have this function A, right? And so when I plug in, let's look at these points. This point here is -1. Now the absolute value of -1 is just 1. But now if I go to do this one, I have to do 2 times the absolute value of 1. So what's 2 times the absolute value of -1? 2 times +1, which would be 2. So that's why this is -1, 2. Okay? And if I go to -2, what's the absolute value of -2? +2, right? So this becomes +2. And then for here, over here, I'm just multiplying 2 by whatever the absolute value of x is. In this particular case, is 2 times 2, or 4. That's why this one over here is 2 times, or -2, 4. That's where that vertical stretch comes from. I'm taking that number and I'm multiplying the y value, sort of, okay, by that factor. Now let's look at this one. Let's graph this one, okay? Now, if I change and I do this with 1/2, when I say x, and I'll just draw like a little line here where I say x, y, or h of x, that's h of x, sorry. If I plug in -1, what's -1 squared? It'd be a +1, so, and then multiplied by 1/2, so that would be 1/2. So that's when you do the 1/2, it shrinks down that y value. The y value would be literally 1/2 of that. So when we have a graph like 2x, or 2 times the absolute value of x, that 2 is going to do a vertical stretch because it's greater than 1 by a factor of 2. Okay? Any questions on that? And so now when we look at this part B, for part B, and you don't have to write all this stuff down. The only thing that you have to write down for part B is the graph and then the numbers. So don't write all these words down. I just want you to maybe write this graph down. So like I said earlier, if I plug in a -1 here, when I square it, it becomes a +1. And then this is going to be multiplied by 1/2, so I get 1/2. So this right here, this number here is -1, +1. But over here in blue, this value right here is -1, 1/2. So whatever this y value is, I'm multiplying it by 1/2. So we say that is a vertical shrink, because it's a fraction, by a factor of 1/2. And we could do one more value if you want. If I plug in -2, what's -2 squared? 4, not 5. 4, right? And then what's half of 4? 2. So over here, if you notice, this is -2, 2, right? And then over here, when this function is evaluated at -2, that one's going to be -2, 4. So what I have here is whatever this y value is, because of this 1/2, what's 1/2 of 4? 2. And so that's why we have that vertical shrinking. By how much? A factor of 1.